planning is demonstrated in OpenNero in the blocks world environment. There is an implementation of the Towers of Hanoi problem that consists of moving a bunch of disks from one pole to another using the extra pole as a temporary landing location. Planning means figuring out what to do before you actually do it. To illustrate this idea, we have three different methods in this environment. The first one is a goal stacking planner, which follows the classical strips approach. There you work backwards from the goal state and search for actions that satisfy its preconditions and recurse that way. Strips-like planners assume that the plan can be constructed by adding actions linearly, one at a time, as you discover them. And of course that's rather difficult in that the actions can clobber each other. The goal that was previously achieved can be undone by a later action. And goal stack planner may not actually notice that. So one fix that is in this algorithm is that if such a clobbering occurs, it will reintroduce the goal and try to achieve it again. And this works fine for instance, two disks in the Towers of Hanoi, as we see in this example. So here in this text output window, we can step through the planning process, or we can skip to the end of the plan and see what the plan is in the end. And then once it's done, Steve will actually go ahead and execute the plan. And it's a pretty simple for this two-disk case. It turns out that in 3 disks, this planner actually fails. It will end up in an infinite loop because it keeps reintroducing a goal that was clobbered and then clobbering it again. So an interesting question is, how do you fix it? You may have to make it a nonlinear planner where you avoid ordering the actions until you know what you're doing. So that's a good challenge for further work.